Hello, welcome to IT Expert YouTube video series. Today we are going to talk about Unified Modeling Language Diagram. Context diagram. Context diagram defines a boundary between the system, or part of a system, and its environment, showing the entities that interact with it. There is no single diagram in UML that would map to this definition, but I have some good news. There are several diagrams out of total of 14 that can show the frontier between the system and its surrounding world from different perspectives. This is much more flexible than only a context diagram. First of all, I would mention a special UML element, a boundary. It can be used in any diagram type to show some kind of delimitation. You might want to optionally use it to visually delimit between the system and its environment, especially in situations when this is not explicit. The following diagrams can show the boundary between the system and its environment. Use case diagram. Your examples support the context explicitly on the functional level. Use cases are elements of the system under development, while the actors are external entities, systems, or human users. Before mentioned boundary is often used to visually delimit between the system and its environment. Component diagram is used to model some kind of software modules, applications, DBs, external systems, libraries, etc. You can use it to show both internal and external components and the way they interact. A boundary can be used to clearly draw the separation line. Activity diagram can show your system or business or usage processes. Some activities can be performed internally, others externally. Here you do not need the boundary, but the so-called swim lanes to depict who does what. Sequence or collaboration diagrams are another option. They show the communication sequences between several objects. If you split those objects in internal and external ones and wrap them up with the boundaries, there is another context diagram. UML is flexible. There are probably further options, but I think this is enough to get the idea. UML use case diagram. A use case diagram is used to represent the dynamic behavior of a system. It encapsulates the system's functionality by incorporating use cases, actors, and their relationships. It models the tasks, services, and functions required by a system or subsystem of an application. It depicts the high-level functionality of a system and also tells how the user handles a system. Purpose of use case diagrams. The main purpose of a use case diagram is to portray the dynamic aspect of a system. It accumulates the system's requirement, which includes both internal as well as external influences. It invokes persons, use cases, and several things that invoke the actors and elements accountable for the implementation of use case diagrams. It represents how an entity from the external environment can interact with a part of the system. Following are the purposes of a use case diagram given below. It gathers the system's needs. It depicts the external view of the system. It recognizes the internal as well as external factors that influence the system. It represents the interaction between the actors. Important tips for drawing a use case diagram. Following are some important tips that are to be kept in mind while drawing a use case diagram. A simple and complete use case diagram should be articulated. A use case diagram should represent the most significant interaction among the multiple interactions. At least one module of a system should be represented by the use case diagram. If the use case diagram is large and more complex, then it should be drawn more generalized. What is test case? A test case is a document, which has a set of test data, preconditions, expected results and postconditions, developed for a particular test scenario in order to verify compliance against a specific requirement. Test case acts as the starting point for the test execution, and after applying a set of input values, the application has a definitive outcome and leaves the system at some endpoint, or also known as execution postcondition. Typical test case parameters. Test case ID. Test scenario. Test case description. Test steps. Prerequisite. Test data. Expected result. Test parameters. Actual result. Environment information. Comments. Use case diagrams. In UML, use case diagrams model the behavior of a system and help to capture the requirements of the system. Use case diagrams describe the high-level functions and scope of a system. These diagrams also identify the interactions between the system and its actors. The use cases and actors in use case diagrams describe what the system does and how the actors use it, but not how the system operates internally. Use case diagrams illustrate and define the context and requirements of either an entire system or the important parts of the system. You can model a complex system with a single use case diagram, or create many use case diagrams to model the components of the system. You would typically develop use case diagrams in the early phases of a project and refer to them throughout the development process. Use case diagrams are helpful in the following situations. Before starting a project, you can create use case diagrams to model a business so that all participants in the project share an understanding of the workers, customers, and activities of the business. While gathering requirements, you can create use case diagrams to capture the system requirements and to present to others what the system should do. During the analysis and design phases, you can use the use cases and actors from your use case diagrams to identify the classes that the system requires. During the testing phase, you can use case diagrams to identify tests for the system. The following topics describe model elements in use case diagrams. Use cases. A use case describes a function that a system performs to achieve the user's goal. A use case must yield an observable result that is of value to the user of the system. Actors. An actor represents a role of a user that interacts with the system that you are modeling. The user can be a human user, an organization, a machine, or another external system. Subsystems. In UML models, subsystems are a type of stereotyped component that represent independent, behavioral units in a system. Subsystems are used in class, component, and use case diagrams to represent large-scale components in the system that you are modeling. Relationships in use case diagrams. In UML, a relationship is a connection between model elements. A UML relationship is a type of model element that adds semantics to a model by defining the structure and behavior between the model elements. Functional versus non-functional requirements. Functional requirements. These are the requirements that the end user specifically demands as basic facilities that the system should offer. All these functionalities need to be necessarily incorporated into the system as a part of the contract. These are represented or stated in the form of input to be given to the system, the operation performed and the output expected. They are basically the requirements stated by the user which one can see directly in the final product, unlike the non-functional requirements. Non-functional requirements. These are basically the quality constraints that the system must satisfy according to the project contract. The priority or extent to which these factors are implemented varies from one project to other. They are also called non-behavioral requirements. They basically deal with issues like portability, security, maintainability, reliability, scalability, performance, reusability, flexibility. Purpose of deployment diagrams. The term deployment itself describes the purpose of the diagram. Deployment diagrams are used for describing the hardware components, where software components are deployed. Component diagrams and deployment diagrams are closely related. Component diagrams are used to describe the components and deployment diagram shows how they are deployed in hardware. UML is mainly designed to focus on the software artifacts of a system. However, these two diagrams are special diagrams used to focus on software and hardware components. Most of the UML diagrams are used to handle logical components, but deployment diagrams are made to focus on the hardware topology of a system. Deployment diagrams are used by the system engineers. The purpose of deployment diagrams can be described as: visualize the hardware topology of a system. Describe the hardware components used to deploy software components. Describe the runtime processing nodes. How to draw a deployment diagram. Deployment diagram represents the deployment view of a system. It is related to the component diagram because the components are deployed using the deployment diagrams. A deployment diagram consists of nodes. Nodes are nothing but physical hardware used to deploy the application. Deployment diagrams are useful for system engineers. An efficient deployment diagram is very important as it controls the following parameters: performance, scalability, maintainability, portability. Before drawing a deployment diagram, the following artifacts should be identified. Nodes. Relationships among nodes. Following is a sample deployment diagram to provide an idea of the deployment view of order management system. Here, We have shown nodes as monitor, modem, caching server, server. The application is assumed to be a web-based application, which is deployed in a clustered environment using Server 1, Server 2, and Server 3. The user connects to the application using the Internet. The control flows from the caching server to the clustered environment. Where to use deployment diagrams? Deployment diagrams are mainly used by system engineers. These diagrams are used to describe the physical components' hardware, their distribution, and association. Deployment diagrams can be visualized as the hardware components or nodes on which the software components reside. Software applications are developed to model complex business processes. Efficient software applications are not sufficient to meet the business requirements. Business requirements can be described as the need to support the increasing number of users, quick response time, etc. To meet these types of requirements, hardware components should be designed efficiently and in a cost-effective way. Nowadays, software applications are very complex in nature. Software applications can be standalone, web-based, distributed, mainframe-based, and many more. Hence, it is very important to design the hardware components efficiently. Deployment diagrams can be used to model the hardware topology of a system, to model the embedded system, to model the hardware details for a client or server system, to model the hardware details of a distributed application. For forward and reverse engineering. State diagrams. A state diagram is used to represent the condition of the system or part of the system at finite instances of time. It is a behavioral diagram and it represents the behavior using finite state transitions. State diagrams are also referred to as state machines and state chart diagrams. These terms are often used interchangeably. So simply, a state diagram is used to model the dynamic behavior of a class in response to time and changing external stimuli. We can say that each and every class has a state, but we do not model every class using state diagrams. We prefer to model the states with 3 or more states. Types of state chart diagram. Structure diagrams. Used to model the static structure of a system, for example class diagram, package diagram, object diagram, deployment diagram, etc. Behavior diagram. Used to model the dynamic change in the system over time. They are used to model and construct the functionality of a system. So, a behavior diagram simply guides us through the functionality of the system using use case diagrams, interaction diagrams, activity diagrams, and state diagrams. Difference between state diagram and flowchart. The basic purpose of a state diagram is to portray various changes in state of the class and not the processes or commands causing the changes. However, a flowchart on the other hand portrays the processes or commands that on execution change the state of class or an object of the class. Basic components of a state chart diagram. Initial state. We use a black filled circle represent the initial state of a system or a class. Transition. We use a solid arrow to represent the transition or change of control from one state to another. The arrow is labeled with the event which causes the change in state. State. We use a rounded rectangle to represent a state. A state represents the conditions or circumstances of an object of a class at an instant of time. Fork. We use a rounded solid rectangular bar to represent a fork notation with incoming arrow from the parent state and outgoing arrows towards the newly created states. We use the fork notation to represent a state splitting into 2 or more concurrent states. Join. We use a rounded solid rectangular bar to represent a join notation with incoming arrows from the joining states and outgoing arrow towards the common goal state. We use the join notation when 2 or more states concurrently converge into one on the occurrence of an event or events. Self-transition. We use a solid arrow pointing back to the state itself to represent a self-transition. There might be scenarios when the state of the object does not change upon the occurrence of an event. We use self-transitions to represent such cases. Composite state. We use a rounded rectangle to represent a composite state also. We represent a state with internal activities using a composite state. Final state. We use a filled circle within a circle notation to represent the final state in a state machine diagram. Steps to draw a state diagram. Identify the initial state and the final terminating states. Identify the possible states in which the object can exist. Boundary values corresponding to different attributes guide us in identifying different states. Label the events which trigger these transitions. What is sequence diagram? A sequence diagram simply depicts interaction between objects in a sequential order, i.e., the order in which these interactions take place. We can also use the terms event diagrams or event scenarios to refer to a sequence diagram. Sequence diagrams describe how and in what order the objects in a system function. These diagrams are widely used by businessmen and software developers to document and understand requirements for new and existing systems. Unified Modeling Language is a modeling language in the field of software engineering which aims to set standard ways to visualize the design of a system. UML guides the creation of multiple types of diagrams such as interaction, structure, and behavior diagrams. A sequence diagram is the most commonly used interaction diagram. Interaction diagram. An interaction diagram is used to show the interactive behavior of a system. Since visualizing the interactions in a system can be a cumbersome task, we use different types of interaction diagrams to capture various features and aspects of interaction in a system. Sequence diagrams. A sequence diagram simply depicts interaction between objects in a sequential order, i.e., the order in which these interactions take place. We can also use the terms event diagrams or event scenarios to refer to a sequence diagram. Sequence diagrams describe how and in what order the objects in a system function. These diagrams are widely used by businessmen and software developers to document and understand requirements. Sequence diagram notations. Actors. An actor in a UML diagram represents a type of role where it interacts with the system and its objects. It is important to note here that an actor is always outside the scope of the system we aim to model using the UML diagram. Notation symbol for actor. We use actors to depict various roles including human users and other external subjects. We represent an actor in a UML diagram using a stick person notation. We can have multiple actors in a sequence diagram. For example, here the user and seat reservation system is shown as an actor where it exists outside the system and is not a part of the system. Lifelines. A lifeline is a named element which depicts an individual participant in a sequence diagram. So basically each instance in a sequence diagram is represented by a lifeline. Lifeline elements are located at the top in a sequence diagram. Rectangle called head with its name and type. The head is located on top of a vertical dashed line referred to as the stem. If we want to model an unnamed instance, we follow the same pattern except now the portion of lifeline's name is left blank. Difference between a lifeline and an actor. A lifeline always portrays an object internal to the system, whereas actors are used to depict objects external to the system. Messages. Communication between objects is depicted using messages. The messages appear in a sequential order on the lifeline. We represent messages using arrows. Lifelines and messages form the core of a sequence diagram. Messages can be broadly classified into the following categories. Synchronous messages. A synchronous message waits for a reply before the interaction can move forward. The sender waits until the receiver has completed the processing of the message. The caller continues only when it knows that the receiver has processed the previous message, i.e., it receives a reply message. A large number of calls in object-oriented programming are synchronous. We use a solid arrowhead to represent a synchronous message. Guards to model conditions. We use guards in UML. They are used when we need to restrict the flow of messages on the pretext of a condition being met. Guards play an important role in letting software developers know the constraints attached to a system or a particular process. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you and resume LinkedIn. Staffing support. Provide tech references. In-person online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.